Okay, this is Mr. Peterson, and this is notes for 2.7 Part A. This is page 4. Forgot to put the title up there, but the title is Linear Quadratic Systems. So this will be the linear part, and with the squared, that'll be the quadratic part. We're going to get a line and a parabola, and I've already pre-printed the parabola over there. Okay, so you notice that hopefully that this is in vertex form right here, and so that'll be the opposite of h, and that'll be k, which tells us the center part right away, and you can see that I went 4 out and 8 up to get to that vertex. If you go to the right, you get 5, 6, and 7, and the other direction 3, 2, and 1. So this will be our table start value when we get there. So what I do first is I go to my y equals key, and I've typed this in already, the equation, and then I'm going to set up my table. So second table settings, I want my table start value to be 1 in automatic mode. So now I'm going to go second and table, and you can see I've got these numbers over here. Good news is that there's symmetry around both sides. So it goes to a height of 6 there, and then it goes down to 0 and 0 there. You can see those two. Those are x-intercepts, are called zeros. This is the one we call the 0 because its neighbor is 0. What x value zeroes out to y? Well, another one would be 2. Those x-intercepts, 2 and 6, are called zeros. And then it goes down to a height of -10, and you can see I've already pre-printed that here. So there's our parabola. It's already graphed, and I drew a solid border. Now I'm going to put the notation over there that I need to be below that parabola, and that's from this less than or equal to. Alright, so now I'm going to turn my attention to this linear equation here, and we'll start by taking that 2x over to the other side. If you divide by -3, that's the time you're watching for. You're watching out for dividing by a negative here, because that has the effect of turning the sign around. So we're going to be above this line when it gets drawn. We can tell immediately that we're going to be dealing with a solid line and shading above. So this has a slope of 2/3 and a y-intercept of -3. So it's going to hit down here and go 2 up and 3 over. And we'll get that plotted here in a minute. You want to stop and make sure that you remember whether it's solid or dashed before you draw it. This one's solid, so we'll draw that line solid through there. And we're going to label it above. We need to be above that line. So what we have here is a situation where we have to be below the parabola and above the line, which kind of traps us in this area up here. Okay, so at the bottom of the page, we have an example 7 at the very bottom of the page. I'll show it to you, that refers back to that one. So we're going to take care of this right now. They want to know if these are all answers or solutions to that graph that we just completed. So the 0.13 is the first one we look for, and you'll see that's right here in the non-shaded region, so that's not a solution. 3, 5 goes next, and that's a little harder to tell. If you go 3 out and 5 up, you're just barely in that green area there, so it is a solution. And then 5, 6 is more obviously right on the border, and that border is solid, so that does count. Put yes there, that's a solution. 6, -1, however, is right down here in the white region, and that would be not a solution. So that does it for that last question, and all we have left is these two graphs to figure out. Okay, our parabola for this next graph here is in standard form. And when it's in standard form, you have to find the value of h with the little formula I taught you. So we're going to take this b value of -4, and on the bottom you can go -2 times the a value, which is that 1 there. And when you calculate this, you get 2 for the center value. So we'll put 2 right there. Branching out to the right is 3, 4, and 5. And the other direction is 1, 0, and -1. And that will be your table start value when you go to the table settings. So first of all, go to your y equals key and type in the equation. You can see I've got it typed in already. Then you go second and table settings, and you want your table start value to match this number here. And then you go to your table, second table, and usually what I counsel students is to go over to the right and down 3 spots, and you'll find K immediately. You can see that would be right here, and then you can see that there's symmetry around that. That's good news. It goes to 3. So there's your next pair of points, and then it goes to a height of 6. Your y-intercept is 6 right there, which in standard form is that number at the end. It's C. Okay? And then we have one more pair here. We're at 5, 11 and -1, 11, and those are technically off the graph, but I'm going to go ahead and fudge it a little bit here and draw my parabola through there. And then I'll look at the formula here. The equation, the inequality is y is less than, so we need to be below that one. Below the parabola. Okay, I'm ready to solve for y on the other one. So your slope on this one is -1/4, and your y-intercept is 8. So we come over here to the y equals 8 on the y-axis, and you go down 1/4, down 1/4 to step out your slope. This is a dashed line. It's the first one we've had on this thing, so we've got to make a dashed line there. And we are supposed to be above that line. So if you think of the point right here on the parabola, to get below that you have to go down into this area over here, and that is above the line. Also here you'd have to go down and stay above that line, so this area here is also part of the answer. So what we have is a split graph this time. We got part of the answer over here, part of the solution set, and the other part is up here. And you'll recall that this thing goes forever to the left, so it acts as a roof over top of this, and that pink area is in fact below the parabola. Okay, the next one here, what we have is a parabola again, a quadratic equation because of that x squared. And let's find h first. You have to find h when they're in standard form like this. This can be b over -2 times a. Sorry, a is -1 there. -1 times -2 is 2. Divided into this gives -3 for the h value. So we're going to come over here with -3. And then we get smaller, bigger first, smaller second. Type the equation into the y equals line. I'm going to go y equals, and you can see I've got it in there. And you set your table up to start at -6, second table settings, and your table start value is at -6. Then you go to your table, and if all's well, you should have symmetry on this side. There's your k value, negative 3, 4. On either side of it, it goes to a height of 3. Then 0 and negative 5. And you can see the y-intercept is negative 5 here. We knew that at the start here because that's the value of c in standard form. So we're going to go ahead and do a dashed graph here. I almost made a mistake there. This is supposed to be dashed. And we're supposed to be y less than below that. So below the parabola. And now let's do the work for getting the y by itself here. Take the x over. Divide by 4. Which lets you know we're above a dashed border whose slope is 1/2 and whose y-intercept is 4. So let's find 4 on the y-axis and count out a slope of, I made a mistake here, you probably noticed, negative, negative. So this goes down 1 and over 2. And hopefully that didn't throw you off too much, but if you're watching the whole video, you'll see me correct my mistake there. Alright, so we're going to draw a dashed border here, and then we'll put the notation on it that we're supposed to be above this border. Greater than, you want to be above the border. Well, to be above that line and below the parabola at the same time is impossible. So there's no solution to this equation. And as a consequence, you'll have no shading. Okay, so you just leave it blank, don't put any highlighter on it. Okay, and that does it for page 4, which is the last page of these notes. So I hope that was clear enough presentation. You can do your homework. It matches pretty closely to this note set.